9th. Well, let's open it up. Come on.
It's not November 9th, it's today.
It is, well, that is today, November 9th. All right, we're going to balance these two equations. I'm going to attempt to do that over here on the board.
Mine is weird.
Remember, it's I don't know if you can copy and paste the off of the image or not to get the equation down in the text box. Remember, you click on the text box here or the submit assignment up here where mine says published. Yours will say submit assignment. That gets you the text box. So we have the first equation, lead, and then silver sulfate. And that is going to give you silver. And then lead sulfate. So the first thing under the arrow I like to do, and so you may have to do it on paper. Would you like a piece of paper, Shane?
I can probably type it.
Or you're going to follow along? I like to put the symbols for each. So I have PB for lead, AG for silver. I'm going to keep SO4 together because it's SO4 on both sides. If that SO4 was split up in the reaction, you'd have to separate it out. All right, so on the left side, I have one, sure I copied it right. No, I didn't. Should be a 2 here. I have one lead, 2 silvers, 1 SO4. On the right-hand side, I have 1 silver, 1 lead, and 2 SO4s. So I'm going to start with my silver here. On the right-hand side, I need to multiply that 1 by 2. And that 2 I'm multiplying by will have to go up in front of AG. So I now have 2AG on the right-hand side. So my silver is good. For right now, it may not be in just a minute because I see a mistake I just made. To get my SO4 to 2, I would multiply by 2. Well, when I put my 2 up here where my SO4 is, what is also attached to that SO4?
AG.
AG. Well, that just messed up my balancing of AG because now I have 2 times 2, which is 4. So I go back to the right side.
4 to AG.
And it's going to be 4. So I put a 4 in front of the AG. So your answer would be PB plus what I call big 2, AG, little 2, SO4, little 4, yield. Remember, if you're typing it, you can do 2 dashes and the greater than sign to get an arrow. 4AG, so big 4, 4AG, plus PB parentheses SO, little 4 in parentheses, little 2. So for those listening to the video, it'll be probably a little harder to catch how to balance these. All right, the next, C6H12O6 is actually glucose, plus oxygen is going to give you yields, carbon dioxide and water. And if you remember from biology, you might remember what goes where in here. If not, we're going to separate these all out. So I'm going to have a C, an H, and an O. And I'm going to put a second O because I have kind of 2 O's on each side. But it depends on how you want to, how best your mind works to deal with the oxygens. So I have 6 carbons, 12 oxygens, and with this oxygen I have 6. Oh, I didn't even write that right, so 2. This one I have 2, so that makes a total oxygen of 8 on this side. This side I have 1 carbon dioxide. One of these Oxygens is a 2, 1 is a 1, and 2 hydrogens, so I have a total of 3 oxygens. All right, I'm going to start with my carbon. I need 6, so if I do times 6 on the right side, that means I'm going to put a 6 up here. And that means for my oxygen where I put the 2, I'm going to have times 6, which is 12. So 12 and 1 is 13. I know I'm not going to be finished there. I'm going to do my H's next. I need 12 H's. So I'm going to go times 6 to get 12. So I'm going to put a 6 in front of my H2O on the right-hand side. That means my O is going to have a times 6. So I have 6 plus 12 oxygens. That gives me what, 18? I'm doing my math right. Well, how am I going to get over here? Ooh, something's not right.
That's what it is.
Six. Oh, I know why. I was jumping ahead. Never mind. I already have 6. So 18 minus 6 means I need 12. How am I going to get 12 with this 2 is to multiply by 6. I did, if you had one O there and you had 18, you would think you would put 9 here. That's where my mind went. I was like, oop, that's not right. So if you remember from biology, you have 1 glucose molecule plus 6 oxygen gases gives you 6 carbon dioxide and 6 waters. If you remembered that this was respiration from biology, you wouldn't have had to balance it. You would have known. So those are the 2 answers. So get those typed and you will submit. And remember at the end of the text box, it's down, the submit is down at the bottom. Just a reminder, these are 0 points you do on the day of class, and you get them correct, you get extra credit points added to your grade. When you get that submitted, you're going to go to modules, and we're going to see what we're going to do today. You're still typing, right, Jane? You're good? Okay. So we are down on November 9th. Remember, you can see more than up here on my screen than you see. So we're going to look at types of chemical reactions. And then Tuesday, you're going to do some more practicing with classifying and balancing chemical reactions. Wednesday's a holiday. There'll be no assignments there. And then Thursday, I will have something up um, probably maybe dealing with acids and bases, not quite sure yet. So we're going to review some more with balancing, and then we're going to do some, talk about types and how to recognize types of equations. So I have 3 up here that I want to balance just to go through so you can see, because in the warm-up it was hard to hear me go through it without actually seeing it. So I'm going to rewrite number 1. Ooh, I'll try to write on this board. Forget that it has a lag. H. I have to write slow. All right. So what I was explaining is I write down my letters on both sides. Now, if you find a letter on the left and you don't see that letter on the right, you've got a problem. Something's not right. You've got to have the same elements on both sides. So nitrogen, I have 2 on the left, hydrogen 2 on the left. On the right, I have 1 and I have 3. Well, I'm not going to start with my hydrogens because they have kind of an odd looking number here. I know if I fix my nitrogens, I might be able to then fix my hydrogens. So I'm going to do different colors. So to get 2 nitrogens, if I multiply this side by 2, and I put that 2 here, that means I also have to to multiply my hydrogens by 2, and that gives me 6. So that means on this side, I need 6, and if I already have 2, if I multiply by 3, I get 6. That 3 that I multiplied has to be the coefficient. So over here, if you had a sheet like this, you would be putting 3 here and a 2 here. You do not have to put a 1 in that first one unless you just want to put it there to see that it is 1. All right, let's look at number 2. KClO3, that's a lowercase l, yields KCl plus O2. So I have KCl is together because it's a lowercase l, not an uppercase I, and an O. This side I have 1 K, 1 Cl, 3 O's. 1 K, 1 Cl, 2 O's. Well, this time I am going to start with my O's because they're the only ones that are unbalanced. So I'm going to switch gears again with my colors. So to get this balanced, if I multiply this side by 2, I get 6. If I multiply this side by 3, I get 6. So what I multiplied by on the left, the 2, goes in front of the 2 KClO3. What I multiplied by on the right, which is a 3, goes in front of the O2. I don't have to do anything else on the right now, but on the left, I put a 2 in front of KClO3. That means that my K also gets a 2, and that also means my Cl also, that 2 goes with because they're all together. So that means on the other side, I have to put a 2 in front of KCl so that I have balanced. So up here, I would put a 2, and a 3. I will give you a hint. If you ever get all even numbers across, you know you have to reduce it because you put too many. All right, let's look at this last one. Maybe I'll have room down here. NaCl, again, that's Cl, F2 yields NaF plus Cl2. So I have Na, which is sodium, Cl chlorine, and F fluorine. So 1 sodium on the left and 1 chlorine, 2 fluorine, 1 sodium on the right, 1 fluorine, 2 chlorine. All right, so it really doesn't matter where I start. I'm going to start just with chlorine. So I'm going to say times 2 on the left-hand side. So that means when I put a 2, I'm also affecting my sodium. So times 2. All right, I already have 2 fluorine. Well, if I look on the other side, I need 2 fluorine on the right side. I put a 2. That is also affecting my sodium. So I should be balanced now. So I'm going to have a 2 here, and I'm going to have a 2 here. So just another review of balancing equations, because you're still going to need to do that for something we're going to do tomorrow. I'm going to hold off and do those the next day. Evidence of chemical change. We didn't talk about this. And hold on. I don't think I put everything I needed up here. No, we're going to have to come back. All right, so one thing I didn't talk about was to know if a chemical change has taken place, you need to see some of these things right here. So when a chemical reaction takes place, you could see a release of light, like a spark. Temperature can change. That means it can get cooler or hotter. An odor can change. You can smell odor. Think about rotting eggs. That's a chemical change, and it puts off an awful odor. A sudden color change, a gas given off, and this would be bubbles, fizzing. It might look like steam, possibly, or a sudden appearance of a solid, and we call that a precipitate. So I hadn't went over that and you need to be familiar with these. what I wanted to talk about, I did not get up here, so give me just a minute to get that pulled up. I thought I had everything ready. All right, I wanted us to talk a little bit about classifying elements or reactions. When you see a chemical reaction, you should be able to know by what it looks like which type of reaction it is. So there are 5 types. There's acid and base reactions as well. But the main 5 that we're going to look at are synthesis, decomposition, combustion, single replacement. Sometimes you'll see displacement, double replacement, or double displacement. So you may see a couple different names. You can think of synthesis as combining. You can think of decomposition as breaking apart. So synthesis, you've got 2 or more reactants. So you want to use this right here and you get one product. So you're going to have 2 things being combined together and you end up with one thing in the end. Synthesis. So you're making something new. Let's see. I'm curious. See. If I can go there.
Hold it.
Yeah. I can do it on the computer better than I can here. Or you know what? I'll copy it. Copy and I don't need this anymore. Paste. And we'll see what it looks like. Maybe.
Writing's not that easy, but Grammarly can help. This sentence is grammatically correct.
So iodine and aluminum.
Today's demonstration is one of my favorites, mainly because it's simple. It just involves 2 elements, iodine and aluminum, and the ratio of the iodine to the aluminum is, this particular one is 3 parts aluminum, so 3 grams of aluminum, 6 grams of iodine. So can we get a close-up of the aluminum powder?
So it's aluminum powder.
Okay. And how about the iodine? Most of you probably have lots of iodine in your storeroom, and you can only make so much tincture of iodine or iodine testing solutions. And so what do you do with it? I mean, we have, I think at my old school, we had over 1 kilogram of iodine. So we try to think of demonstrations that we can use that use up some of the materials that we have in the storeroom, trying to get our volumes down a little bit so we're not storing so much of those materials. And chemical demonstrations are a very, very good way for you to be able to do that. And also, I like a lot of the history of how the periodic table was developed and so forth. And here we are using 2 elements. So we could teach this during synthesis if we were talking about chemical reactions. We could look at the charges on these if we wanted to. We could talk about compound formation. We could talk about a whole bunch of things. And really, it only takes about 2 minutes to set this up. Once you have your iodine and aluminum, then you're good to go. Now, one thing about the iodine is it comes in chunks. I mean, it comes in fairly large pieces, and so you need to have a mortar and pestle, and you need to grind it into a real fine powder.
So the solid
now,
iodine has to be
a lot of things you don't
ground.
want to grind, but iodine is perfectly safe. You can really grind that up into a very, very, very fine powder, and then you want to keep them separate until you're ready to do the experiment, because the iodine and the aluminum is going to be activated with a few drops of water. So if you live in a humid part of the country, these could go up, if you make like some people like to make 5 setups in a row for all 5 classes during the day. This is not a particular demonstration that you'd want to be able to do that with, because You'll do the one would
It
work
takes a little
fine,
bit of
and the
water
other
to
four
make
would go
this
off in the
start,
hood
and
at
if it's
random
very
times
humid, and you go
without
in
your.
and mix it, it will
Sometimes you'd
cause
be in the
a
room,
reaction.
sometimes you wouldn't be in. And you do need a fume hood for this. What I'm going to do is I have the aluminum here and I have the iodine, and so I'm just going to pour them together. Maybe.
He's taking the iodine and putting it into the aluminum.
Okay. And then once I have them together, I'm going to mix them. And again, you know, they say be careful when you're mixing, you know, oxidizers and so forth. Well, this is pretty good. This is not one that I've ever had any kind of problems with, other than if it's real high humidity. I can already start to see some purple vapors in here. I don't know if we can get a little close up of that, if you'll be able to see them. But the iodine and the aluminum, it's already starting to change color a little bit. And then what I like to do is I like to mound this up and to make a little, kind of like a little hill of it. So I'll lay it flat so I can do that. And then make a little depression down in the center. So I can add the water. So can we see that? Great.
So put the water in the middle.
And again, see, it's already starting. I don't know if you can see this. I haven't done anything to it yet. All right, so that's why you don't want to pre-mix these ahead of time. So I'm going to add a few drops of water and then stand off to the side. And again, practicing these things with your colleagues is great. Oh yeah.
So in this case, it took the water to get it to finish.
And away we go. What was said earlier about colored gases are poisonous. So again, remind the kids about that. I mean, look at that. Isn't that beautiful?
Wow. Flame. And he said colored gases are poisonous. You don't want to inhale that. Not sure why he would not be doing this under a hood.
And that'll go for several minutes, so the kids have plenty of time to write questions, ask, you know, make predictions, do all that.
Right there. No. All right, so this is an example of a synthesis. Now, each of these, I'm going to post the PowerPoint. Each of these has one of those in sort of, or may have one in the notes that you could actually click on your own and look. We might look at the others, I'm not sure. Decomposition, you're going to have one reactant, and it's going to be breaking down into two products. So that's sort of use your AB yields A plus B. Have you heard of elephant toothpaste? This is an example of this. So we'll see how quick this one is. Paste.
Hi, my name is Elise Klifkin, and I am an undergrad at the University of Wisconsin-Madison, and I will be
All right,
performing
so I'm going to put the
demo called
captions on
Elephant
again
Toothpaste,
since you can't
and it
hear
involves
them at
hydrogen
here.
peroxide, which constantly breaks down into water and oxygen. But
All right,
I'm going to add a
basically this
catalyst,
is hydrogen
potassium iodide,
peroxide
which
being
makes the
broken
reaction
down
fast.
into water and
In the
oxygen.
cylinder, there's hydrogen peroxide and a couple drops of dish soap, which will allow us to
Add
see the
dish soap.
reaction occur. This is potassium iodide.
Potassium iodide.
As you can see, the reaction was catalyzed and all the oxygen was released, and the dish soap, makes the foam with the oxygen, and that's why
Oxygen is being released.
called elephant toothpaste.
They put the soap in it just so you can see the color of it. So that was a decomposition. That one at least was quick. All right, then we have combustion. Combustion is when something is going to be burned, and it's always going to have oxygen as a reactant. So one of the reactants will be oxygen. The products will always be carbon dioxide and water. All right, so it doesn't matter what else is with the oxygen, but there will be oxygen gas as a reactant and carbon dioxide and water for the products. Let's see what they have here. So if we have calcium, that I think it's chlorate, and you'll get, it'll decompose into calcium chloride and oxygen gas. That's decomposition. And then you've got combustion. If you take this glucose, oxygen, in other words, respiration, it's the breakdown, it's what respiration does. It has some combustion going on there. And so we're going to, oh, that one was going to link right to it. See what they do here. Oh, well, how would that violate YouTube's community guidelines? I guess we will not watch that one.
What video?
This was an old video, so whoever's over YouTube must have decided that the murder of a gummy bear was violating, probably because they used the word murder.
Or it's like, because it's gummy bear, it might be violating CAPA.
Yeah, I don't know. Who knows? All right, one element, single replacement. One element replaces another. I like to call this kind of the one spouse decides to leave his or her spouse and move in with another person,
Okay.
or divorce and hook up with a new person. So you've got copper.
It's a weird
Well,
analogy,
yeah, well, it works.
I guess.
You have a couple here, silver and nitrate, they're together, and it could be a dating relationship. And then copper comes along and attracts nitrate and pulls it away from the silver. So you've got a single replacement. One element or compound has been, or one element replaces another element. So copper has come in and replaced silver. This will usually be a metal. Here's another one, zinc. Zinc comes in and replaces copper here. And so whatever metal is by itself on the left is going to be with a partner on the right. Let's see what they have here. Rusty nails is an example. Of course, they didn't highlight this or underline that one. So
Let's make devil's toothpaste. Is elephant's toothpaste.